Good morning and welcome back. I'm continuing this adventure towards creating a little role-playing game. We're a mini micro. Let's have a refresher on where we ended last time. We load our main file and run. We have one little dude in a big empty blue world that we can move around with the arrow keys. The horizontal and vertical axes as defined by Unity. Actually, I'm pretty sure. Hit escape. Well, escape still doesn't work. We'll get to that in a minute. What I'd like to do this morning, we'll see how far we can get, is incorporate the sprite controllers system file from the mini micros built-in library and see if maybe we can get a second character on the screen that we can interact with in some way. So, the first thing I'm going to have to fix is that like right now you have to hit Control C to get out of here, and that's just not. I don't know. We can be better. I think I'm going to map the exit action to code 27, which is the escape key. Turn that back on. Disabled it last time when we switched over to using the axes. So hit the exit key, set an is done flag to true. Initialize to false. While not is done. Clear. Graphics clear. Print. Goodbye. Let's see what effect that has. Aim. Run. Move around a little bit. Hit escape. Well, it does print a goodbye. Just doesn't clear everything. Now the problem. We're clearing the text and graphics. We're also using the solid color screen. Split that to the right. Hopefully that's not too hard to read. We want our display types there. And down here, we are going to do text clear, graphics clear, display, clear that. And set the solid color background back to black. Let's see if that will clear everything. There we go. I wish the little goodbye message was at the top instead of the bottom, but I think that is sufficient. I don't want to spend the next hour on clearing the screen. All right. We don't need that chunk. Going to keep my debug message because as soon as I remove a debug message, I need it again. That's just the way it goes. So the first thing I want to do, we're going to learn about the spriteControllers library file a little bit, and then we're going to put a lot of these variables into an object. So you can see the way mini micro is set up. Looks sort of like a retro computer. It has two like virtual disk entries here. USR for user. There's a user 2. I don't know why someone would use both disks. I guess, I don't know. You would have to ask around. I've only ever needed one at a time. Get a directory of the root file system. You got a system directory and a user directory. Inside of system, got that chunk. See, there's a little lib. Make this bigger. There is a lib folder. Look into that, and there is sprite controllers. Let's look at that. There's a lot of things in here. I'm going to try to incorporate as much of this standard library as I can, just because I can. I just want to see what it can do. Okay, so helper classes to help control sprites. I read over this a little bit before starting this video. The emphasis seems to be on platformer games, which is not what we're doing here, but it has the animation class, which will be useful. We have the new animation function, the list of frames, and frame list is an image. It's an array of images. It's simple enough. It can be one image, or it can be an array of images. There's a speed that we should be able to set off of the animation class, and a loop flag. Scrolling down, we can clone animations. Seems ill-advised, but maybe it's a good idea. Just we'll come back around to that. Define a sprite subclass for any sprite that uses animation. So animated is what we'll start using instead of sprite in order to use this. Then it has an update. Cool. Delta time. DT is delta time. I think this is in seconds. That would go with the fact that the time function is in seconds. Our method set the given animation as the current animation. Start over from the beginning. Cool. Input pressed equals function key or value. Interesting. I don't think we need that or the move towards just yet, with it. Move one value towards another value. We might end up needing that for moving multiple sprites around the screen, but we'll see. Like I said, this looks like it's designed for platformers. Jumping, falling, climbing. Probably not using those. Probably just going to use the idle for now. So a lot of that platformer stuff is just going to get ignored. Scroll, scroll, scroll. Update sprites function, which goes through the displays sprites array and updates everything that is animated, which is cool. So let's see if we can start incorporating all of this into our demo. And here's where we ended yesterday. See, we have some constants defining what the sprite's going to do. We set up our screen, load our images. This is that animation array that we need to feed to the animation object. And let's start doing this. Let's see, when we import this, I'm going to see if it imports into the global namespace or it dumps it into a spriteControllers namespace. Let's import it. Import spriteControllers. Anything in the lib folder, you can just import. I like to keep things alphabetized. It's just me. So we got that. We need to change our sprite type to this animated type. If we find the sprite, is null. I think I'm going to comment this out until I know exactly what we're doing with it. Right. Set the given animation frame. So you got this play function that we should be able to feed an animation to, which is just an image array. So we have the image array. So impressed if this works right off the bat. We have the update sprites function. So theoretically, we should not need our own animation loop. We should be able to call spriteControllers update. Delta time. How's delta time used? Well, that's passed into the sprite's update method. Where's the sprite update method? Current animation apply to, so it's then passed to the animation's apply to method. Delta time, time to the next frame. It's like it's essentially doing what we were doing. It's a little bit fancier, which is nice. This is controlling for the frames per second. May or may not come to bite us later. Do need to capture that delta time. So let's go ahead and do that. Say delta time equals time. No. Delta time equals 0. Second. Last frame time equals time. Delta time is current time minus last frame time. Do that there. You know, I've done this so many times, and yet it feels like a fresh experiment every time I re-implement it, which is kind of funny. Well, let's run it. Reset, load main, run. Let's watch this blow up. Delta time is unknown. That'll help. Let's define it before we use it. Update, not found. Oh, it's because it wasn't called update, was it? So look at that file again. Sprites. Like so. Apply to, not found. Now that is more of a personal problem. There's sprite. So I'm not setting up the animated sprite properly. So let's review that again. We need an example of how to do this right. If only there was an example. I'm pretty sure there's an example. Sys demo platformer. Let's look at that file. All right, so in this demo, it is importing sprite controllers. It creates an animation object, which I did not do. I just kind of shoved something in there. It has a tile util. We're gonna have to come back around to that probably in another video. All right, so about that animation. So new animation shoves it onto that animation property. Says current animation to whatever animation you want. So basically, I need to use that new animation function and then feed it a pile of images. I think. Well, let's do that. Rerun. And hey, it's stronger little guy. He's way too small again, and he is not animated, but he's there. And that's kind of nice. It didn't explode. It doesn't do everything we want, but it also didn't break. Put the scale back. Okay, back to full size. Now let's figure out how to actually make this guy animate. So what could I have been doing wrong on the animation? I have a weird feeling about the delta time. Let's just dump that value up to the screen. Problem is, I'm doing subtraction between time and that last frame time, and there's not really a whole lot going on there. And I'm betting that's just dumping out a pile of zeros. It's going to take a long time for that to get to 0.3. That is just not going to do. Okay, so the animation might be working, but it's just so slow that you're never going to see it. You know what? Let's just go see what that demo was doing. Control F for find. Is there DT? Time minus last time. Weird. Last time's only ever calculated once here. Am I reading that right? No. No, it was recalculated here. That's a good idea. Let's copy that. It's mostly common knowledge that when programmers copy code, it's not actually stealing. It's just something that everybody does. We all copy each other's code. There is nothing new under the sun. Even if I were to write this all from scratch, I would still be pulling something from my memory that I got from somebody else. Uh, let's see what that does to delta time. Hey, look at that! The little guy's bobbing again. Oh, that makes me so happy. He's a little too energetic. The animation speed was controlled by a value in the sprite controllers. So let's look at that again. Animation speed equals 1. What's that? Let's see if speed was sealed in return. So make sure I'm thinking about this right. The speed is not calculated exactly the same as what I was doing. So I'm not sure if we need to increase it or decrease it. So let's just play with some numbers until we get something we like. Could be that it's toggling the frame once a second. No, he was moving faster than 1 frame per second. Was that off of the animation or yeah, it's on the animation object. So let's go back up to animation. Split it two. Let's see if he goes faster or slower. It is. Gotta watch those typos. That's the thing. Learning to program, you are going to get really OCD about punctuation and spelling. Alright, kind of makes sense. Double the speed. Now he moves twice as fast. Cut it in half. I can live with that. Cool. So let's clean this up just a little bit. Don't need the angle. This guy's not going to spin anymore. We don't need his animation stuff because the library is doing it for us. Yay! Go ahead and check that in while I'm still thinking about it. Use spriteControllers branch. Cool. All right. Now what we are going to do, I want to group this into a game entity type. And so we're going to talk about object-oriented programming in Miniscript for just a second. It's actually kind of interesting. So let's say that I'm going to create a point type to hold X and Y point. I mean, you would start by basically create a new map that's going to contain your type. And then you can create a function to initialize it. Point dot make equals function x and y. Self.x equals x. Self.y equals y. There's a lot of ways to do this. None of this is hard-coded. Right? As a make function. So p equals new point dot make, because you actually have to create a new instance of that map. Basically, the new function is going to subclass the point, create a new map with an hidden is a property set to point, and then it's going to call the make function off of the point map to populate it, basically. So create a new point. Look at P, and I did something wrong. Well, there goes that demo. Oh, p equals new point. That returns the point. Make does modify the object, but make doesn't return anything. P equals new point. P.make35. There's P. X, Y, is pointing up to the point object, so P is a point. Yep, it's a point. P is a number. It is not a number. But what's really funny is that you can do this. I'm pretty sure. A is equals a new P. You're actually allowed to do that. A is a P. Copies all those objects down. Uh, I've never had I've never had a use for that, but it feels like there must be some arcane use for subclassing an instance of a class. Anyway, basic introduction to object-oriented programming mini-script. There is a pattern I usually follow. None of it is really set in stone. So we are going to have another round of cleanup. Decide exactly how I want to do this. To group some of this together. A lot of like player. Anytime if I start sticking a label at the start of a variable for a whole group, the same label for a whole group of variables, it's a sign to me that it should probably be grouped together. We're just going to go player type. I, I usually have two functions here. Yeah, an init function just initializes all the state variables. And you have a make function as considered a static function that actually creates the new instance, initializes it, and returns it. And then we actually also have a second type of object going on with the sprite sheet, which I'm going to try to encapsulate now. It'd be more useful to start with the sprite sheet definition. It's going to start, you give it the path to your image. So let's save that. Load the image. And then we need to capture this concept of like grabbing a sprite by index, an image by index instead of doing all this rectangle math. So let's just have a get function. Do some math. Think about this for a minute. Once we get these two classes going, I'm probably going to stop the video there. So it's like a tile sheet. Tiles per row. Let's see. Width divided by sprite. Instead of a 0. Problem. Let me look up that player file again. You just count that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and just kind of going across like that. Which might be too much to ask for in round 1, so I think I'm going to give it an X and Y for the tile position. We'll fix that later. Sprite width and sprite height could stay where it's at. Back to that. X times sprite. They return it. And actually, if the sprite sheet thing works as is, I'm probably going to stop it there. And let's give that a try. And 53. That off. The arguments in 69. That'll help. You know, something didn't break. That needs to be a +1, so it doesn't just grab the first sprite off the edge of the image. And there we go. There's part of them. Do that to both. That works. We don't need the raw image anymore. Yay! Let's go ahead and commit that. And I really would like to turn that into a single index. See if I can do that right quick. So the x value should be index mod tiles per row. The y value should be index divided by tiles per row. But you also need to floor that so it doesn't, you need to lop off the decimal point. Let's see if that works. Okay, so still bounces, but that's index 0. If it really works, the real test is, can we grab one of these other guys? Like, let's grab this little archer dude. That'd be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Archer dude is 26. So if this actually works, big test, go to 26. And there's Archer dude. Oh, that's exciting. That's going to make it a lot easier to switch between sprites. So I've talked about as long as I want to for this video. I think I'm going to pick up on trying to add a second sprite in on the next video. But we did get some object-oriented programming lessons in. We got the sprite controller incorporated, got the code cleaned up, which is nice. And yeah, subscribe to the channel if you want to keep seeing these videos. Feedback is always great. I welcome everybody's feedback. Still kind of new to this whole video recording thing. And oh yeah, where I go, the code that I'm writing here is being uploaded to GitHub. Posting this link in the video description. But if you wanted to follow along, pretty easy to download a copy of this mini micro. It's basically go miniscript.org/minimicro, download whichever edition you want, and you can start playing around with this thing. So you're always welcome to ask me if you need help getting that going. And that is it. See you later.